Takeaway number 2, DeepSeek employed a new training method for DeepSeek R1. R10 could represent a paradigm shift in how we think about model development going forward. We
Right.
discussed
R
that
R R10
explicitly on the last
R10 is
show.
more important than R1.
Yeah,
Because R10 is it, in it developed the ability to think independent of human guidance. It is
right.
just pure reinforcement learning. And again, the limitation with R10 is not that it's not a good model. It's that it wasn't very human legible. It had poor readability. And so there's a bit where they had to do stuff to make one of the things they did with R1, for example, is they introduced a reward function to make sure it always stayed in the same language. Because
Mhm.
R10 will switch between English and Chinese and all this sort of thing, which is a readability problem. That came at a performance cost. It made it perform worse in some respects. And so there is a real bit where to make these models human accessible actually makes them worse. And you think those in the context of, if you're going to, like, the more RLHF you do, and this has been documented for years, the more RLHF you do, you do decrease model performance, because in some respects you're asking it to not follow its core learnings, its
Right.
core
You're
weights,
weighting
but to
it
sort
down.
of that's right. And so just in general, the R10 is me, and this idea that everyone's been trying to do this RL, just pure RL for these sorts of things, but they did get it to work.
Mhm.
And that is, like, to me, that is in the long run, it really reinforces this aspect. So the whole distillation thing reinforces the power of synthetic data. If you
Yeah.
like
That's
these
the
models,
signal amidst all the noise the
that's
last
right. Well,
couple
number
weeks.
two
That's
is
what
this
will
is this
matter.
RL bit, which is the model can make itself better without human intervention, and that means much more scalability in the long run in terms of improvement, a much more of a virtuous cycle in terms of AI making AI better. And again, it's very appropriate. We've spent the last few months talking about the bitter lesson. It's a reinforcement that the bitter lesson holds. It
It's
holds
getting
even for sort of
really
thinking.
real. Yeah.
Yeah.
Okay. So 3 more takeaways. DeepSeek's V3 model was trained for $5.5 million. Could be evidence that the cost structure of US AI companies will be unworkable long term. And then some people are extrapolating further that means the US stock market is about to collapse and Nvidia in particular is going to come crashing down.
Well, so
Takeaway
okay.
number 4.
I mean,
Okay.
how much do you want to dive into this one? So the big takeaway here, again, we've been on it. The economics of the absolute cutting edge model has been questionable for a while
Hmm.
because of the distillation issue, which is much cheaper to serve. Who is going to actually create the leading edge model if everyone else is going to make money off it except for them, and you don't get a return on your core initial investment? And so that we talked about that a lot, sort of with Nat and Daniel, sort of last week. There's a bit where just the belief and pursuit of AGI and that it's going to sort of break away is sort of critical and essential, because the economics of model serving are kind of falling apart if the way it works is one team invests tons of money to build a model, everyone else distills it and serves it way cheaper.
Yeah.
And that, I think that's part of Microsoft's bit about sort of bowing out of the training bit, which is, look, we're here to serve our customers. You go off OpenAI. If SoftBank wants to fund it, that's fine. We're just going to distill it and serve it, and that's going to be fine from our perspective. And it's a very sort of rational sort of thing for them to do. So that's the real question there. You think about that, that's good for Microsoft stock. Like,
Hmm.
cheaper models and more efficiency is a positive thing. They would, like, the big hangover, if anything, for these companies is how much they're spending on CapEx. If that CapEx
I was
could be
going to
used more
say,
efficiently, or they could
they're
sell,
spending
like, this is
$80 billion this year. And we didn't mention Satya's iconic quote last week, talking about Sam Altman and the funding for Stargate. I know I'm good for my 80 billion. It's pretty great. So great job by him. But
it
that would
really
be
is.
the obvious follow up is like, all right, so how much longer are shareholders going to tolerate people spending $80 billion
Right.
a year on this
It's great for
technology.
Amazon. Amazon is the other big winner here. Like they who cares if they can't make a model? They don't need to make a model. They can just serve all these other models and they can do it even more efficiently than you thought. This is good for Llama or good for Facebook. Like it's kind of bad right now. Llama's not super efficient. It's probably a wake-up call for their team that they've been spending way too much money and they could be doing this probably much more efficiently. But in the long run, Facebook's costs are going to be dominated by inference. And inference being cheaper and models being cheaper is good for them. Now, the big question is Nvidia. So if the Nvidia has two big moats. Moat number one is CUDA, which is the language everyone uses to program this stuff and sort of make it work. I think that is still pretty strong. Number two has been their memory bandwidth infrastructure. The idea that you can loop they bought Mellanox, they have InfiniBand, they have NVLink, they have all these things that sort of lets you treat a massive fleet of GPUs as one GPU, and it sort of handles all these sorts of things. That is the precise efficiency that DeepSeek found. And so there's a bit where, at least in inference to start, the plausibility of if you don't, of other chips, if you could run all this on just one chip, suddenly the memory bandwidth isn't as important. Maybe for the absolute cutting edge, it really matters, but does it matter as much for the trailing edge? Are other possibilities that maybe aren't as good as linking all their GPUs together as NVIDIA is, or as seamless as NVIDIA is? Are they more plausible? That is a fair concern. Like it was just sort of assumed NVIDIA is going to dominate.
Concern. And also, if the big tech companies reduce CapEx going forward, I mean, most of that CapEx has been going to NVIDIA and like external power.
Well, so this gets to the other question, which is the sort of product overhang point that we've been talking about for ages. Like the optimistic take is there's something called Jevons Paradox, which is the cheaper something gets, actually the more it is used. And
a lot of people were citing Jevons Paradox over the last couple of days on tech Twitter, or particularly among AI anon Twitter. So get into it.
Yeah, so the idea is actually the limitation on AI usage right now is the cost. If it actually goes, and again, we've been talking about this for all 200 episodes of Sharp Tech. When and if AI inference goes to zero from a decision-making perspective, as it happened with GPU or CPUs going to zero, the reason you can have a Google search, the reason you can have a social network, the reason you can have these ad platforms that run these auctions and cycle through a gazillion possibilities and finally target and serve you one is because you assume that the compute costs are basically zero. You sort of optimize from that. To the extent we get there and makes like sort of GPU computing that much cheaper, that at least in the long run should lead to more usage of GPU computing, not less. And that is a positive thing. The question is, what use cases are not possible and not being done right now because of cost, right? Or is the issue that people haven't created compelling enough products for people to use that makes them sort of, and so this isn't like a long-term issue, but it is a sort of dip issue. Are we going to feel the pain of the product overhang, the lack of products leveraging this stuff more acutely? Is Nvidia going to feel it more acutely because we just haven't fully leveraged these capabilities such that Jevons Paradox can sort of take hold?
Well, wait,
and so it's almost more of a timing issue.
Jevons Paradox. What exactly is Jevons Paradox for anybody who's curious out there?
That when the cheaper something gets, the more usage increases, and the amount of usage actually exceeds the sort of price that comes down. So the limiting factor on using GPU workloads is the cost of GPU workloads. And if those come down, actually the usage will not just increase, it will increase exponentially such that the overall value of GPUs actually goes up, even though it's cheaper.
Not going to run out of customers in that scenario.
Right. And so the question is what is the ceiling? What GPU use cases are cost limited right now? Like, are they cost limited or are they product limited in that people just haven't built compelling enough products to use it more?